Hello everybody, welcome back. So in the last tutorial we made this tails turn towards the old location where, the old position of the snake. So in this tutorial we're gonna clean up, remove the dots, and we're gonna make the speed and swirl and so on. And hopefully we're gonna have time to add the avoid position as well. So first off, we can just start with delete these two debug dots. So now you see they are actually bending the tail towards where we're gonna go, or where the old position was. So we have the rotate, and now we're actually gonna create the speed, and the speed we're gonna use to add into the swirl, well, speed of course. And we're gonna have some, we add some swirl amount here. So the speed gonna represent the swirling like that. So each particle gonna have their own speed variable. So we're gonna do custom attribute, and it's gonna be a float and be a speed. And we're gonna make the speed down here. So we can, if we do the get velocity, we can work out the speed here. So if we do the length of the velocity and get custom attribute, and we get the speed, so we get the speed from the last frame. And if we take the last frame speed value and we add on the current length of the velocity, we can update the speed and therefore animate the snake. So we need, in the update particle, we need to set custom attribute, and it's going to be speed, a float value. And if we plug it in here, then in the shader we can do read get custom. We're gonna take the speed value float and we plug it into the speed, and now it's animated. So there, it's going really fast. So let's see what we can do. It feels like I missed something. They are so fast. All right, so let's see here. It's get velocity. We do the length. All right. So the velocity we need to. It's very high value. So the velocity is calculated. I think it is per second, but we update the value per frame. So it should be approximately, maybe it's 60 frames a second. So we need to take the delta time and we need to multiply this value with the delta time, and this should sort it out. Okay, yeah. So now it is animating, but it's really slow. So now we're actually going to add a multiplier. Multiply, I think 10 could be a good value. Now you see there is different speed on it. So so now we fixed that. So this is super nice. Let's see if I have everything. Yeah. All right, so there's actually another thing that we're gonna sort out right away. So let's say we have we do 100 of them, and we're also gonna do this size. We're actually gonna have them different sizes. So if we do save like this, you can see that the small one, they need to be much faster in the tail, but the big one looks pretty suitable, but the small snakes need to be much more quicker and we can compensate it. So because we have the size here, so set size, we have the variable. If we down here actually divide, so if the size is 1 and we divide with 1, we keep the value. But let's say if we have snake that is the half size, that the size 0.5, and we will divide it, it will be, the speed will be the double amount. So then we just take get size like this, and then we compensate for different sizes as well. So now you see, if we look here, the small one are much quicker, and the big one, they are a little bit more relaxed. So that's good. So now we have compensated for the sizes as well. There are sometimes the turns doesn't really look so good. I'm gonna check it out. But first off, we have the speed here. Set speed, and we get rotate. It feels like there is something back direction. So I think this float value here is a little bit, the lerp value. I'm going to change it for, instead of 0.001, I'll change it to 0.01. So if we check this thing out, it's going to lerp much faster to the wanted back direction. And when they turn, yeah, this looks so much better. So that's what I did. I changed the lerp value to be much stronger. It's not perfect, but it's good enough. So that's nice. Also, I want a swirl amount. I want it to be, so the swirl amount is how many swirls it is. So if I do like 7, you can see there's a lot. I only want 2. And I think the swirl, I think it's a little bit too much. So what we can do, we can actually calculate. We could leave it as it is, or we could actually change it. So let's change it a little bit. So what we could do, if we do the velocity, get the velocity, and we get the length, and so this is actually values that I tried out to find out it works. So you can just tweak it around if you don't like it. But if I just take the, if I take the length of the velocity and take the half amount of it and put it into the swirl amp, there is a reason why I did it, because I want it to be, when they are when they don't move much at all, it's less movement. And if I do a minimum with this one, and I add 0.15 here, I will always never exceed 0.15, but it can be less. So what I'm doing here, sometimes the zigzagging is really weak, but sometimes I want it to be as much as 0.15. So then I take the minimum value of the length of the velocity or 0.15. So I find this a really nice value. So now we got this one, and we are going to do. So let's do 500 and see how it works. Yeah, so now we're starting to get something. We're gonna change the colors. I want some different colors on the snakes. So we can do that. And we don't need to change everything, but let's say we keep the we keep the we keep the black guys as there are. So here the color, let's do, I think green could be nice. And we have the orange, and let's randomize the orange color. And let's do even more snakes, so we can 5,000, so we can see. So now it's very same colors, but I think it's nice if we break it up. So like make a color and open it up, and now we can actually do this random number, and we're not using constant. So let's do this in the red channel, and actually I don't want the same random value input in the red. I want two different random values in the red and green, and then I just plug it in to the body one. So this is nice. Now we got some different snakes going on. Cool. And now the last parts we're gonna do. We're gonna make this position where the snakes avoids. So if you want the player to go through all these snakes, maybe you want the snakes to avoid. So I'm gonna show you how to do that. And we're gonna so the avoid part needs to go in the force part. So in the update particle we have the force, and in the force we're lerping between the noise force here and also the center force. So when they go too far away from the center force will kick in. And I have let's see. So we need to add an input here. It's going to be actually two of them. We're going to make a vector free, and we're going to have this going to be named avoid position. We're also going to have this float value avoid this distance. We can actually just set this distance to 3 right away. So this avoid position, so now at the start it's going to be 0, 0, 0, but we're going to update it later with the script. So we need the position, get position of the particle, and we need to subtract the avoid position. So I can show you. So if you so let's do it like this. And if we do in a Photoshop, we do a new one. I think you will recognize this, but I do it anyway. It's good to be super clear what I'm trying to do. So we have this This is the VFX center, and we will also add a red we're gonna all right, let's see. So this circle gonna represent where they're gonna where they're gonna avoid. So if we do, so this has a position as well in the center here. So let's take this snake over here. So what we want to do, we want to take let's see what I'm doing here. In this here we do the position subtracting the avoid position. So that means we take the position and subtracting with this one. So what I mean by that, so this position and this position, if you subtract, if you do A minus B, you will essentially do this. And then you actually created a vector like this. So once you made this calculation, you have this vector, you want to normalize this one. And this direction, you add it to the particle like this. And then you know when it's too close, you want to add this go away force. So let's see. I hope I'm not too vague. Hope you follow. I'm gonna make some more space here. So now we have this position that I've been talking about, well direction. So we need to normalize it. And we also need to know how far is it. So we need to know the distance of the distance here, right? So it's very easy to do. So we have the position and we made the direction, and then we just do distance. No, we're not. We are doing the length. The distance is between two vectors, but we are actually only measuring one vector. That's why we're using length. So we have that, and then we do actually, so let's see. So now we need to lerp. So we actually need to lerp between the same way we did before. So we need to lerp from the, so watch here, I'm doing the opposite here, because what I do is, if the distance is really short, that means it's really close to the avoid position, then we need to have this force. But if the length is really high, we want to use the original noise going on. So in order also to have this length, we don't want to overshoot the value in the lerp function. So we could use clamp, but we're going to use saturate. I think saturate is more optimized, cheaper to use. And we're also going to do floor. So this means that this will only kick in when it's really close. So if we do this and plug it in and save it, now they should avoid the center. And so we have this avoid distance, and the same thing we did the last time. We divide it. So if we use after when we have the length afloat. So now you see that we have it at 3 units and the size is much bigger. So now they will always avoid the center. So we can actually just try it out. So add the X value here, and now we see the avoid this center. So this is super cool. So the last thing we're gonna do, we're gonna add in the scene, we're gonna add a spear, and we're gonna this spear, we place it in the center. Well, actually here. So you can see the idea is that when it's here, the VFX graph gonna read it, so it's gonna, so we can control it from the outside. So let's do that. So we need a script to solve this, and we're gonna make create, and we do C# avoid. Just waiting for it to load up, and eventually it will. All right, so here it is. So we don't need the start, and we're actually gonna add this we're gonna do execute in edit mode, so we don't need to start, press play. If we add this, the script will update in the edit mode. And that's good, so we can just see everything live. And we're gonna have, actually we need using Unity engine.vfx. So we're gonna have a visual effect. We're gonna have avoid awake. So when the script is added, it's gonna do the awake function, and the visual effect is gonna be get component visual effect, because we're gonna add it on the visual effects game object. So this one's gonna be populated right away. And we also want to have a float size. Well, let's skip it. I'm not sure about this one, but either way. So we're gonna need a public transform. We're gonna have a sphere transform. And this is gonna be the sphere that we created. So now it's so simple. So in this void, you just need to do visual effect, set vector free. We're gonna do the void position that we named. So we need to make sure it's the same name. And the value we want to do is sphere transform dot position. So this should be, yeah, this is old notes. I forgot about it, so we just remove it. So this is what you need. So in Unity, just let it work a little bit. So the VFX object, we just add the script here, And if we do this public, you will see that the visual effect is assigned to that variable. And there it is. And we need a sphere here. And now we can just move this thing around like this. And it works. So we're gonna add so there is another thing I want to add, because when they turn, they can snap and make a really sharp turning. So the turning looks a little bit snappy. But also I want to make sure that the velocity is a little bit faster. And let's see. All right. So we're gonna, okay, so what we're gonna solve is that they are not they don't care so much about the space, because what we need to do, the negative force they get when they get too close is too weak at the moment. So the way to solve that, we can do it fairly easily. So we have this this is the avoid part that we've been working on. So let's just make more room here. We're gonna move it here. We just do avoid force. We have the avoid force, and now so here we divide to compensate for the size of the sphere's force. And then if we only add a multiplier to the normalized value, so this one has a value of 3, and if we just add it here, we actually make the force much stronger. Or we can just hard code it. Actually, I don't think it makes sense to always have it pretty strong. So now it really represents its boundaries really a lot. So I think I covered everything that I want to cover in this series and tutorial. So we could add some shadows to the snakes. We see there's no shadows, right? So if we go into this output particle lit, that's where we can change that. So if we do, let's see, shader, cast shadow. Now we have some, it should be some shadows. If we do save, maybe. Oh yeah, it is shadows. So now you have everything set up. Of course, there's a lot of things we can continue to do. I've been thinking a lot about stuff, but I need to break it here so I can put it in other tutorials instead. Now we can just move it. Yeah. So thank you so much for watching, and I really hope you enjoyed it. So thank you so much.